In this video, we are going to talk about how to solve exponential equations. So when we take a look at these, so now you won't see any logarithms in here. You'll see bases since these are exponentials. And so we're going to get a couple that can be the same base so that both sides can be written in the same base. So we'll see on this first example that both of them have a base e. So all we're going to want to do is simplify this right-hand side first. So this left-hand side is just still e to the 4x minus 1. And then we'd have the power rule here, so we would just multiply these. So this will be e to the negative 2x. So if their bases match, then that means the exponents must be equal. Okay, so these two pieces must be equal. So we would have 4x minus 1 equals negative 2x, and we would solve. So I'm going to add 2x to both sides to get those x's together. So then we would have 6x minus 1 equals 0, add 1 to both sides, and then divide by 6. So we would end up with an answer of 1/6. So over here in this next example, again, we're going to be able to get these written as the same base. So you may remember 243. So 243 being maybe 7 cubed. Nope, that's 343. Okay, so let's take a look here. So 81. So 81 can be 9 squared. It can also be 3 to the 4th. Okay, so 3 to the 4th is 81. So let's see if 243 is a power of 3. So 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. Okay, so 243, what do we do? 2 is 9, 3 is 27, 4 is 81 to the 5th. So then this is 3 to the 5th power. So I'm going to rewrite 243 as 3 to the 5th power. And then you still have this exponent 2x plus 4. Now I'm also going to rewrite 81 as a base of 3. Okay, so 81 is, like we said, 3 to the 4th. And then we still have that exponent of x plus 2. So now these have the same base. So let's again use the power rule here. So we're going to multiply the 5 with this exponent. So we're going to get 10x plus 20 when we multiply 5. And then here we're going to multiply these two together, 4 times x plus 2. So we have 3 to the 4x plus 8. So now that you have the same base, again, these exponents are going to be equal to each other. So we will just set those equal to each other. So 10x plus 20 equals 4x plus 8. So I'll subtract 4x from both sides. Then subtract 20. So 8 minus 20 is negative 12. Divide by 6 and get negative 2. All right, then we can get to some that cannot be the same base. So 10 is not a power of anything except for 10. And 63 is not a power of 10. So these cannot be rewritten as the same base. So instead, what we're going to have to do is undo the base by doing a logarithm. Okay, so this is a base 10. So now we're going to do a log of the same base. So a log base 10. Again, you don't have to write the base 10 with a log since it's just automatically understood that it's a 10. I'm going to, just so you can see it. So then log base 10 and base 10 exponential would cancel, and we would be left with just the exponent of x over 4. And then on this side, we have log base 10 of 63. So then we can, I would just leave this for right now, log base 10 of 63. I'll show you how to evaluate it in a second here. But then on this side, we're just going to multiply by 4 to both sides. So I would just write it out front of the log so it doesn't get confused with that 63. So you just end up with x equals 4 times the log base 10 of 63. And so what we don't want to do is end up multiplying this 4 inside of the logarithms. You can't bring anything into there. So now when you go to evaluate this, now this is a base 10 logarithm. So we're just going to be able to type in 4. So I'm just going to do it on the Desmos calculator. So 4 log of 63, because again, the base is normally a 10. If the base was something different in the Desmos calculator, okay, so you'll see, so you'll see the calculator down here. Then you can, you have the number portion, and then let me bring this in here a little bit for you. Okay, so you have the number portion, right? And then if you hit ABC, you see this little button, okay, that has that B below the A. So if you type that, you'll be able to get in a subscript, and you'd be able to type in whatever base it was, arrow over, and then type in your input, and you'll see that we get that same answer as had we not had this base 10. Okay, so 7.2 or however many decimal places they want you to have your answer would be the answer to that one. This next one, so we want to isolate the exponential portion. So the exponential portion is just e to the x, where here we had the 10 to the x over 4 was already isolated. This one has a 50 out front that we need to get rid of first. So we're going to divide both sides by 50 to get that by the e to the x by itself. So we're left with e to the x equals 10. Now you've got an e base. Okay, so if you remember, the e base is just a natural log function, so we can just do the natural log to both sides. And so when you do the natural log, that's a base e, that's going to cancel here. You're just going to end up with x equals the natural log of 10. And then you can go ahead and type that into your calculator. So for this one, we would just type in the ln of, what was it that we had? Just 10. Okay, so ln of 10, and you get 2.3. Okay, next one. So again, we've got this exponential part that we're trying to take care of, or that we're trying to get. So we need to isolate that 3 to the x minus 5 first. So we're going to divide both sides by 6. So we would get 28 divided by 6 equals 3 to the x minus 5. And you could simplify this, divide both by 2, so we'd get 14 over 3. I wouldn't do the decimal yet because I would keep it in exact form until the very end. Now to get rid of a base 3, we're going to do a log base 3 to both sides. So we're going to have log base 3 of the 14 over 3. And we're going to have log base 3 of the 3 to the x minus 5. So I just did the log of both sides. The log base 3 and this base 3 will cancel. So we'll be down to log base 3 of 14 over 3 equals x minus 5. So then we'll just add 5 to both sides. So we'll have log base 3 of 14 over 3, and then plus 5 equals x. And so I would leave it like this until the very end when you go to type it in, okay, so that you keep it in exact form for as long as possible. So now we've got the log. We're going to need to use this subscript button so we can get a base 3. And then parenthesis 14 divided by 3. Close that parenthesis, and then add 5, and we get 6.4. Next one, so we'll divide by 4 right away. So we'll have 19, or sorry, that is wrong. Don't divide. There's a plus 8 there. Sorry, I missed that. Okay, so there's a plus 8, so we'll subtract 8 from both sides first. So we get 11 equals 4 times 3 to the 5x. Then we'll divide by 4. So 11 divided by 4 equals 3 to the 5x. This is a base 3 again, so we'll do a log base 3 to both sides. So we'll have log base 3 of 11 over 4. And then we'll be doing the log base 3 of 3 to the 5x. Which that log base 3 and that base 3 will cancel. So we'll be left with log base 3 of 11 over 4 equals just that exponent of 5x. And then we'll divide by 5. Okay, So then we'll type that part into our calculator. So we will do the log base 3, which we already kind of have here. So I'm just going to do log base 3. And this time it was 11 over 4 on the inside there. So 11 divided by 4. Close that parenthesis. And then this whole thing, oops. And then this whole thing divided by 5. So 0.184. And however many decimal places you would need for that x. So isolate the exponential part first, okay, by doing whatever you need to, in this case, subtracting 8, dividing by 4, then doing the log base. All right, then let's take a look at this word problem. So this one says a person invests $3,500 into a bank. The bank pays 4.75% interest compounded quarterly. To the nearest tenth of a year, how long must the person have the money in the bank until it reaches $5,800? Okay, so we know what the output is. We want to know when it will reach $5,800. We also know the initial investment or the principal amount was $3,500. Okay, and then this is what we wanted out. And then the rate is 4.75%. So this is 0.0475. So 0.0475. This n represents how many times it's compounded. Okay, so this is compounded quarterly, meaning 4 times a year. So the n is going to be a 4. And then a 4 up here as well, another n, and then times t, and t is what we are solving for. So you're going to go ahead and simplify the inside of this parentheses. So you're going to do 0.0475 divided by 4. Plus 1, and inside of that parenthesis, you're going to have 1.011875, and then to the 4t. So we need to isolate this exponential part. So we're going to divide by 3,500 to both sides. And now I'm just going to leave it like that. I'm not going to do it to the decimal just because I don't feel like it. I'm going to type it in once at the end. So now we have this 1.011875 to the 4t. So we need to undo this base. So we're going to do a log of that base to both sides. So log base 1.011875 of this whole thing. Okay. And then remember that the log base will cancel this. So we'll just have equals 4t because we did that log base to both sides. So now you're just going to divide both sides by 4. Okay, so then you'll have this piece that needs to get typed into the calculator to figure out the decimal answer. So we'll do log, and then again the subscript, and then 1.011875. Okay, arrow over, type in parentheses, that was 5,800 divided by 3,500. And then you have that whole thing divided by 4. So 10.696. And then we'll see what the problem asked. So the problem said to the nearest tenth of a year. So then we'll take this 9 and round the 7 up. So the answer to this is 10.7 years to the nearest tenth of a year that it would take to reach $5,800. And then final one, element X decays radioactively with a half-life of 5 minutes. Okay, that's your H in this formula. If there are 520 grams of the element, okay, that's your initial amount or your A. How long to the nearest tenth of a minute, which would be your time, would it take the element to decay to 92 grams, your output? So we have 92 grams is what we want to figure out when it will be. It started at 520 grams with a half-life of 5 minutes. Okay, so this 0.5 was from the formula. T is what we're looking for. H is the 5 minutes. So we'll divide both sides by 520. so that we get down to 0.5 equals t over 5, or sorry, 0.5 to the t over 5. Then we'll do the log base 0.5 to both sides. Okay, so when you do this log 0.5 to both sides, right, the log base 5 and the 0.5 will cancel over here. So on the right side, we're just going to have t over 5. Then we'll multiply both sides by 5 to get that bottom 5 gone. And so then we end up with 5 times log base 0.5 of 92 over 520 equals t. So then we'll type that into the calculator. So we'll do 5 times log base 0.5 of 92 divided by 520, and we'll get 12.5 if we round that. So our t would have been 12.49. This wanted to the nearest tenth, so we would round up to 12.5 minutes for it to get to 92 grams.